Vehicular and flying networks. So this is vehicular and flying networks. So actually it is there in module number 8. So actually this comes under module number 8. Module 8. Okay. So after the completing, we will go with the module number 6. So vehicular and ad hoc networks. So we call it as VANETs, and this we call it as FANETs. So vehicular ad hoc networks and flying ad hoc networks. So these two are the two different technology, and that can be able to talk for the next 10-20 years. It will be on the networking side. Okay. So vehicular networks is using the technology called V2X. V2X means vehicle to everything. So that is called as V2X. Vehicle to everything. Vehicle to everything. Okay, so that is called as V2X. Okay, anyway, we'll see that. Okay, now we can see an example here. What is meant by a VANET? So technologically, I mean, we will see in the laboratory. We will see some experimentation this day after tomorrow on Friday. We'll see how to use vehicular network simulation. So we can call that as a digital twin also, but we will see how vehicular network can be simulated, and how we can able to run this example in it. So we will check with that. Okay, we'll do some experimentations by Friday. Okay, I mean based on these aspects. So it will be very good for graphical processing. It will be very good for animation one. So those things we will see. Okay. Now RSU we have in this diagram we have RSU, something called as RSU, called as roadside unit. Roadside unit. Generally in MQTT we call this as broker. MQTT broker. This is called as MQTT broker. Okay. Now we can see the entire road have many vehicles, and there is side road. There is another road, side road there, and this, and here there is an accident. So here at this location there is an accident. Okay, so there is an accident in the left lane of my area. So this is a roadside unit, and there is an accident met. Now this roadside unit sends the information to another roadside unit. Okay, and this roadside unit sends an information to this roadside unit. Okay, so likewise in the next 10 kilometers or 5 kilometers, according to the implementation, the messages will be transmitted from one roadside unit to another roadside unit. Not only that, so this we called as V2I, V2V, and I2V. So vehicle to infrastructure, vehicle to vehicle, infrastructure to vehicle. So that's what we call it as V2I, I2V, and V2V. So infrastructure to vehicle. Okay. So this is what these RSUs can able to do. Okay. Now this RSU tells the vehicles that accident ahead in the left lane, merge right. So that means this RSU is telling that there is an accident at the left hand side right. So all of you please move to right side. So this RSU is telling. But whereas this RSU says that because there is already an alternative route available, so it says that accident ahead in the left lane, take exit to avoid traffic jam. So it asks them to exit. So see that there is a yellow vehicle which is moving in the left hand direction. It might have been moved to left lane, but there is an accident by the roadside unit, so it automatically moves to the left hand side. Okay, so this is on this is an example of vehicular ad hoc networks. So generally we call it as VANET means vehicular ad hoc networks. Okay. Now here some of the properties of vehicular ad hoc networks is it uses moving vehicles as nodes to create mobile network. All cars fall out of range and drop out of network. Other cars can join in, connecting vehicles to one another, so that mobile internet is created. So main challenge here is the mobile internet is created. So cars can able to talk to each other. So we call it as V2V, vehicle to vehicle. It's component of intelligent transport system. That is intelligent ITS, intelligent transport system. Upon implementation of VANET, it collects and distributes safety information of potential accident by warning drivers about the danger before they face it. So that means warning system. So VANETs are useful for warning systems. It's actually countries like India, it never happened, it never matured, but there are some European countries, they just already deployed the RSU, roadside units. So the roadside units are helpful for taking care of the passenger safety system and accident response system. So that is what these VANETs are helpful for. So maybe it takes another 10-20 years in India to come here because of the road network. So though our road networks are very good, but there are many road networks which is not up to the level of becoming smart. So that's why it could not be possible, but at least in some of the highways they may be planning to do. So now in the vehicle to vehicle communication, we have obstacle in front of this car. You can see there's a yellow color obstacle in front of the car, and behind it there's a truck. Behind it there's a truck here, and behind the truck there's a car, three cars there, and one car says that object to the left. This white car saying that when you try to take a left, already there's another object there. That is one more car is there running in the left hand side. This car doesn't know what is happening, so it is planning to go for a lane change because it doesn't know anything what is happening in front of this truck. So it simply wanted to change the lane. Now how this can be happening? So now you can see here there is an emergency event. Right. So there is an emergency event means accident, inter-vehicle communication, and vehicle to roadside communication. So you can see that there is an accident. That information is being sent here from this car to this car, from this car to this car, and from this car to this roadside unit, or roadside unit to the car, and from this to this car. So likewise, the roadside unit can able to communicate to the cars, and the cars themselves can able to communicate to the roadside units. So that's what we were calling that as V2X, vehicle to everything. Okay, so the characteristics of FANET will be high and fast mobility, then rapid topology changes, predictable mobility, time management, medium access control. So these are all some of the properties or characteristics of FANETs. So high and fast means there will be high number of vehicles and mobility will be fast. Topology changing will be very rapid. So means that the vehicles which are coming in the road, they can able dynamically change their routes. They can have dynamic plans. Whenever there's a accident, they can able to take the alternative routes. So something like that, the topology will be keep on changing and it is rapid. Predictable mobility means sometimes we can able to identify the routes. So one good example, if you take Google Maps. So whenever you are moving in 100 km/h, the destination time it will be showing you. You will be reaching by 7:10 p.m. So something like that it will be showing you. If you go by 60 km/h, then it will say you will be reaching by 10 p.m. Something like this. It will be showing you. So that is called as predictable mobility. So VANETs, it's a predictable means based on the speed of the vehicle, what you drive, and based on the traffic conditions on the road, the Google Maps or any map software, they can able to measure the distance traveling and the time by which by what time you can reach. So maybe you might have wondered how Google calculates that. It's always whenever I put my Google map and then I start driving my car, usually I wonder that how Google is exactly calculating the time. So even many a times when I start from my hometown, it's almost 450 kilometers from Chennai. So whenever I take train, I take my car there. So though I travel from 80 to 100 kilometers, not beyond 100, I never go beyond 100, but 80 to 100 will be the nominal one. So whenever I take it, always tells the same timing. So let's say if it tells 1:10 p.m. if you reach, so by exactly by 1:10, 1:07, 1:08, 1:12, like that I will be reaching my time, my home. So I don't know how Google calculates that the timing, because it is called as predictable mobility. So based on your driving condition, since you have a phone with you, the phone and other traffic conditions in the map, it calculates that. So some of the trends that V2V, Internet of Vehicles is another one. So like Internet of Things, we have Internet of Vehicles. So all cars are having internet connectivity, so they can able to talk to each other on road and off road. Then vehicle to everything, V2I or V2X. Then in vehicle communication, car infotainment. So car infotainment means audio, video playing in the car. Protocol design and short range communication. So sometimes if you want faster data communication, you can go for short range communication. So like radar. So we have something called as radar, radio detection and navigation. Then we have something called as DSRC. So there is a protocol called as DSRC. So dedicated short range communication. So that's called as DSRC protocol. So this is a kind of a protocol where they use in vehicular networks, where they use for the faster communication between vehicle to vehicle and vehicle to infrastructure. Okay. So these kind of trends are been there in the VANET network. Okay. Now intra-vehicle communication. So within the vehicle also they can communicate to each other. So if you have your car with you with the advanced car system, so your car will communicate to many information. So braking system. So one of the powerful and the method is the braking system. So applying the brakes and supplying the reduced air fuel mixture into the cylinder. So that is called braking system. Crash sensors. So whenever your car crashes, so that data will be recorded by the sensors and stored on the onboard diagnostics. OBD, we call OBD. So OBD means we call it as onboard diagnostics. So then we have engine control unit. ECU means engine control unit. Engine control unit. So this is the major the car engine. Stability control is electronic beam. So one good example for stability is ABS, anti-lock braking system, adaptive cruise control. So these two. So ABS was a dream 10 years and 15 years ago. So now it becomes a default standard in most of the cars. So that is called ABS system. Then steering, electronic steering. So earlier electronics, the steering were controlled manually, but now electronic or power steering, which is controlled by motors nowadays. So once you started taking your steering, it goes. There will be a motor running that makes your steering operate very easily. Then lighting system. So lighting system is very powerful nowadays. So while lighting system is see earlier days when you switch on the headlights and then you forget and go home, then by the time you come after an hour and then check whether your battery is good, your battery will drain completely. Your battery will drain because your headlights are powered by battery when you switch off the engine. So in the case nowadays, what happens is some of the cars, even if you switch on the light and you go, after some 5 or 10 minutes later, automatically the light gets switched off. So the cars have these kind of small additional benefits there. Then tire pressure monitoring system. So you have rear tire left one and right one and left two, right two tire. So all the what's the PSI. So 31, 31, and then 27. Then 21. So that means the rear tire 2 have to be filled up. So the air has to be topped up or nitrogen has to be topped up because it has only 21. So we need minimum of 32 for example. Then in that case it will be filled up. Then seat belt sensors. So we have seen that seat belt sensors. So if you don't wear the seat belt after you board the car, then it will give a warning thing. Then power distribution and connectivity. So these are all the power means power across the entire car, how it is distributed and how connectivity like Bluetooth, Wi-Fi and all the connectivity between the components. That's also one of the intra-vehicle communication. So communication within the vehicle with the different components of your car. Next thing is flying ad hoc networks. We generally call as FANETs. So you can see that there are 4 kinds of flying networks. So first thing, the bottommost one is terrestrial network, earth network. So we have wireless communication, we have wireless routers for houses, and we have wireless ship ad hoc network. So a ship ad hoc network means between ships, how the ships can able to communicate with each other using ship ad hoc network. So next thing is UAV, unmanned aerial vehicle, UAV, or simply we call as drone. So drones are low altitude systems. So drones, helicopters, and generally we call copters and drones. They are all low altitude things. So these things. So usually whenever you come to Air Force Tambram, they say Air Force Tambram. Usually when you come in the evenings and the mornings, you can able to see the low altitude helicopters will be flying here and there. So they will be from the ground station almost maybe for example 500 meters away from the ground or 100 meters above the ground they will be flying. So that is UAV. Next thing is aircraft network. So what they call is 32,000 feet at a height of 32,000 feet. So mostly your aeroplanes. So whenever you travel in the aeroplane, they will be flying it. Above the high altitude network, we have called as satellites. Satellites. So 32,000 kilometers above the Earth's surface or something like that. So we have these satellites. So these are the different kind of networking. Now here, FANETs. We have the applications here called as military, surveillance, and rescue operation. This is where FANETs have been used mainly. So rescue operation means you can send a VANET to for rescuing the trapped kids, or if there is any flood or any natural calamity occurs. So how the drones can able to safeguard people. So only for this purpose they were using. And military and surveillance, it has been useful for longer period of time. So long period of time it was used. It was used. Now the new thing is coming up is the e-commerce. So if you take Amazon, they are already doing some research on making the drone. So what do they do is, if you have a house, let's say if this is the house, okay. So now here we have something called as a box. Okay, there is a box in the terrace of your house. Okay, this box is by default it is closed. So a drone comes with and just open the box. So this box gets opened. After that, the product will be delivered. The product will be dropped into the box. Once it is dropped, the drone will fly off. Okay. So the drone fly off. So here in this case, this is a drone. This is a box which is for delivery. Once the delivery is done, the drone will fly off. After the drone fly, the box will send a SMS to you. The SMS, because if the box may be having an SMS gateway, and the box will be sending an SMS to the concerned person saying that the package has been delivered. So then you climb the stairs and then get the box and get the delivery. So this is how the way the initial patent was done by Amazon for delivering this kind of products. So e-commerce, maybe in the next 10 years to come, maybe instead of the delivery boys, the drone may come to. But there are some limitations because the drone cannot be accessible everywhere, and only in the terrace they can be there. So if there is the terraces of the low lying house areas, how it will be servicing, that is still a question mark. But still the technology is not matured. But very soon it can be a reality. Very soon. So in the next 5 years also it may be possible for a reality. So this is on application of FANETs. So now the comparison between FANETs and VANETs. So we have seen mobility. In VANET we can see the mobility is medium and here it is high, and topology change slow and steady. In FANET we have rapid and speedy. Then node distance low, node distance much longer. Power consumption low, it's very high. So flying around because the power consumption is very high. Whereas VANET it is low. So very near to ground level, very high to ground level. So from the ground level it is very high, but it is very near to ground level. So low thickness, no density, and high computational power. So actually the VANETs I didn't go very deeper into it because we will see an example on how the vehicular network can be planned. I'll tell you variety of work that how we can able to do on vehicular and ad hoc networks, because it is one of my prime area which is there for cyber physical systems. And I will be showing you how we can design how we can able to make an electric vehicle to run on a road. Then many other things we can able to see. So on this VANETs. Day after tomorrow we can able to see. So conclusion, I think VANETs and FANETs are for the tomorrow's future, and it can